Hello students, our today's topic is projection. In previous lectures, we had discussed that how we can map the world coordinate description of an object onto a viewport or a physical device coordinate. In that case, the both things were 2D, two-dimensional, using window to viewport mapping and transformation. But displaying three-dimensional scene on a two-dimensional surface is difficult, and it has remained a challenge for the artists, designers, drafters and architects for many years. So 3D viewing, the 3D dimensional world coordinate description of the object in a scene are first converted to three-dimensional viewing coordinate. Then the three-dimensional viewing coordinate need to be projected on a two-dimensional viewing surface, that is called viewing plane or a projection plane. So projection transform point in n space to m space, where m is less than n. What it means? Projection transform a point in 3D space to 2D space. Here m is less than n. Okay. In 3D, we map points from 3D space to the projection plane along projectors. Is perspective projection, another one is a parallel. Be realistic, that is the perspective projection look realistic, but although in parallel projection it looks less realistic, but it is good for exact measurement. And look at this example, it seems to be less realistic, but the measurement and angles, all things are. This is an example of the orthographic projection. Here the projectors are orthogonal to the projection surface, fall perpendicular to the view plane. In this case, the projection lines fall perpendicular to the view plane. Direction of the projection lines that are parallel with each other is perpendicular to the view plane or projection plane. Orthographic parallel projection is commonly used to produce view of 3D object for the various faces that I have already discussed. It is used for displaying the principal face, top view of the building, side view of the building, front view of the building. So advantage is it preserves both distances and angles. Shapes are preserved and can be used for measurement of building plans, manuals. So cannot see what object really look like, that I had already discussed. The parallel projection, the parallel projection do not give the realistic view of any object or any plane. However, the perspective projection, in which the exact dimension of the images cannot be preserved, however it gives a realistic look. Axonometric projection, that we had already discussed, that we can see the three different faces of a cuboid at once on a 2D plane. Does not look real, but far objects are scaled the same as near objects. It is used in one of the major application in CAD. Next is the oblique projection. This is an arbitrary relationship between projector and projector plane. In oblique parallel projection, the parallel projection lines do not fall perpendicular to the view plane. However, in orthographic projection, we had discussed, there is projection line falls perpendicular to the view plane. But in this case, the lines do not fall perpendicular to the view plane. They are inclined by some angle, say theta. That is the direction of the projection line along the which the object point are projected is not perpendicular to the view plane. Oblique parallel projection are commonly used in the industrial drawing, but are not very suitable for working drawings. You can see the various examples of the oblique projection on the screen. Here the lines are not perpendicular to the view plane, however they are inclined by some angle. It can pick the angles to emphasize a particular face. The plane oblique, elevation oblique can be obtained. Angles in the faces parallel to the projection plane are preserved while we can still see around a side. In physical world, we cannot create with simple camera, possible with special lens. So this kind of projection can be obtained with the help of a special lens. That we were discussing the types of the oblique projection. One is a Cavalier projection. Here tan theta is equal to 1, that is the theta is equal to 45 degree. This means the projection line makes an angle of 45 degree with the view plane. So all lines perpendicular to the view plane are projected with no change in length. That is, there is no foreshortening of lines that are perpendicular to xy plane. However, such lines are perpendicular to the view plane with the inclined angle with the horizontal axis of the view plane depending upon the value of the angle, that is the another angle, that is phi, can take the value 30 degree and 45 degree. The next one is a cabinet projection, in which it makes the angle of 63.4 degree. So another commonly used type of the oblique parallel projection is cabinet projection. Here tan theta is equal to 2. So tan theta is equal to 2, that is why theta is equal to 63.4 degree. This means the direction of the projection makes the angle 63.4 degree with the view plane. Due to this, lines perpendicular to the view plane are projected one half of their length. That is, there is a foreshortening of lines perpendicular to the view plane. So in that case, in first kind of oblique projection, there is no foreshortening of lines. However, in the another type, the foreshortening of lines is there, almost half of the length of the lines. So in such case, the inclined angle with the horizontal axis, the view plane, depend upon the value of phi. That is, it again lies between the value of the phi lies between 45 and 30.